Okay. This is a head of the table, right? This is a head of the table. We do something like this. It's maybe not necessarily to same same as this. Okay. And this is another function, right? Okay. And from the problem, we know that h, we have to integrate from 0 to h. We integrate from 0 to h, and uh, h is equal to 30, right? Okay. And from the problem, for the problem, we would like to use uh 20 part, right? For n is equal to 20. N equal to 20, right? So for h is equal to 30 foot, okay? It's 30 foot, right? And n equal to 20, right? Okay. So for the part, the height of each part, it should be what? It should be 30 divided by n, right? Are you okay? And this for the first piece, right? We will do for 20 number. Okay. And it's starting from 0, right? Okay. It's maybe okay. Now we have 30 part. Okay. Are you all right? And then we will determine for FC, right? FC. The formula is what? Is here. Let's go to what? Equal to 300 times C divided by plus 5. Okay. Power times, sorry, times exponents of minus 2 times Z divided by H. H is equal to 30, right? Okay. Are you all right? Okay. Then for the last term, it should be the same. Okay. And for the odd number, it should be, we change to be this cell. Right. Am I correct? We select actually the odd number part. Okay. You do the same thing for even number. Okay. Are you all right? Okay, this is for FC, right? And then we determine for CFC, right? CFC is equal to what? It's just equal to C times FC, right? Okay. And this is equal to are you okay for that? Okay. This is equal to next is the function for moment. Okay. CFC, right? CFC. Because we would like to determine the centroid. To this step, do you have any question? Are you all right? Just determine the function for integration. And we do the same thing, right? For the last term. And for odd number. We already finished, right? Okay. And for trapezoidal rule, we use this formula. Okay, we will working for trapezoid at first. Okay. We have the summation for each column over here. Okay. So for trapezoidal rule, the forces We will determine for force at first. Okay. This for the total one, right? After integration. Is equal to what? For trapezoidal rule is equal to h over 2, right? S now is equal to 1.5, 1.5, right? S is equal to 1.5. S is equal to 1.5. Divided by 2, right? Okay. And times what? The first column, right? Okay. That is the first and the end. Plus H. H is 1.5 for this term. Term what? Term each term. Term each term. That means that we have to use these two columns. Are you okay? This is total forces. How? Okay. And for Simpson is equal to what? Is equal to h over 3, right? 1.5 divided by 3. Okay. And times the first column. Okay. Can you follow me? Plus 4 times this column, right? For the odd number. Plus 2 times the even number, right? That's all. Okay. It should be powerful. And it should be the same. Right? And for the centroid is equal to what? Centroid for this time is equal to, it use this formula, right? CFC divided by integration of FC. And the solution is over here. Okay. The solution for trapezoidal rule is 13.1189. But for sin is equal to 13.0575. Are you okay? Okay. Do you understand? It is very easy for trapezoidal rule and things like that, right? We can use the same table, we can use same table. Okay. Can you follow me for this question? Yeah, great. You all right? Okay. Okay. So this is just the end for two problems, right? For the trapezoidal rule and Simpson rule. Now we will use Gauss quadrature 4 points. 4 points Gauss quadrature. Okay, 4 points Gauss quadrature for this problem. To this example, do you have any question? You have any question? No? You can follow me? You can complete the table right now? What we sell?
FC tổng con FC con
Actually, it is the same. I would like you to not mention to the formula itself too much. Okay? Just understand the concept. And you will know by yourself what should be in the cell, what formula should be in the cell. Okay? It's not necessary to follow these every step. Okay? The formula used in the cell come from this formula, right? Come from the forces function. This is a forces function. It comes from the forces function. So then, it's not necessary to remember the formula itself. Okay, this comes from the forces function. If you know that what is the forces function, you just type across and then see how to use this value rate. Okay, just like that. And for this is the C time F. Okay, C time F. So then we already have FC rate. Okay, just multiply this C, that is alright. Okay, for that. No question, right? For the problem that it change the function, just change the function, right? For another problem that we may have different functions, you just change the function, but the procedure is just the same. Are you okay for that? Are you alright? So I can moving to next, right? I can move to next method. Okay, as we have learned from Monday, right? We know that we have three methods that I teach traditional fix and do it calculator. Which one is the better? Give the base solution for us now as we study. Which one? Which one that you prefer to apply for the integration? Actually, I normally inform you that I teach you three methods, right? But it is your choice to select which one should be the suitable method for use for applying in each application. Okay. Sometimes trapezoidal rule is the best choice. Okay. in some cases, Simpson rule is maybe better. And in some function, Gauss quadrature give us very precise value. Okay, as we know that Gauss quadrature give us very precise value, but in some cases it's not practical. Okay, in some cases it's maybe not practical. For Gauss quadrature, we create a table. Is maybe we will use this formula, right? Microphone is failed. So I will not use microphone because it's fail already. It's completely fail. So I know it's okay. So I will not use microphone. If you cannot hear me, should come in front of the class. Okay, please help me that. Okay, so for Gauss quadrature, we use this formula, right? Okay, and we will use for Gauss point. We will use for Gauss point. So then we have to select this table, this value from this table, right? Okay. We use this value, right? Okay. So this I also we have four Gauss point. 1, 2, 3, 4. Right? Okay. Weight factor. Okay, for the first value is am I correct? Am I correct? Please help me to check myself. Okay. All right. Okay. And then weight factor is what? We select the value from the table. Okay. And then from function argument, we will determine for xi, right? Xi. That is for this case is equal to zi. Ci equal to what? For these cases, we have the integration term. Limit of integration is from 0 to 30, right? Okay. So fc is equal to here. This function. Okay, this is ci. And it's equal to what? Is equal to a plus b divided by 2, right? Plus b minus a divided by 2 and times what? Times theta. Okay. And we got that for these cases. The first point, it should be 2.08. And for another point, it's become like this. You okay for that? Now we have fc, we have z equal to this. And we will determine fc. I will copy this function, right? Okay. This is fc. fc is come from the force function. We already determined from previous table, right? From previous table. And we have the force like this. Okay. And if we would like to determine ZFC, right? ZFC for the function that for the another function, we have to integrate two functions, right? We integrate two functions. What CFC is equal to this time this, right? Am I correct? Can you follow me? Okay. In Excel, when you copy something, you can drag. Select this point and then you drag. It's very fast. Okay, or you may double click or something. Okay, I think it's very basic. So then I use it. I think you already know, right? Okay. So we already have this table, right? Okay. To complete it, we have to determine WIF. Okay, we have two functions. This column is for the function of forces. This function is for moment CFC, right? So we integrate these two functions. So we have two columns for WIF FC. And WIC FC, right? This for another function. And it's equal to what? So this case is equal to WI time FC. And it should be the same, right? And it should be WI times CFC, right? Okay. Are you okay? And after that, we sum. And this is the integration. We will determine this term, the summation, for each point. Okay. And in order to find the integral, we have to determine multiply by b minus a over 2, right? Okay. And d is equal to what? That's the end. And it is a solution, right? Okay. Solution for Simpson for calculator is equal to 12.9. You may compare trapezoidal rule, Simpson rule, and calculator. Okay. What do you think? We have three solutions. Which one should be correct? Now we don't know it because these three methods, these three solutions is the numerical method. Okay. And which one that you prefer? What do you think? If you have to select one solution, you will select which one? You will select down. Okay, you select down. Another one? Which one? Can you determine this function by your calculator? Can you use calculator to integrate these two terms? Can you use calculator? Please try. Use calculator to determine the integration term of this function. Determine this from calculator. Just input in your calculator, right? You put this function in your calculator. You take from 0 to 30. Use your calculator. Use your calculator. So what value is that? Use this function. And another function is just multiplied with C. 300 C. And so on, right? For the first one, you get it. Right? But your calculator give us the exact solution or not? It give us the exact solution or not? No, it give us the numerical solution. Remember that. Okay? It give us the numerical solution. It's never give us the exact solution until you can integrate it by hand and substitute by between the function that you already integrate. That's what we call exact solution. Right? The first one, they say they can help. Okay. So from calculator, we found out the we have this value and this value, right? And after that, we obtain the centroid is equal to 13.05. Okay, so you see it may be close to Simpson rule, right? In these cases, you will see that our Gauss point, our pro-Gauss point is not give us a good value comparison with the calculator, right? I will not tell that calculator is the exact solution, but based on the new technology, your calculator actually, if you study the manual of the calculator, it's used the concept as the calculator, but it's used 15 Gauss point. Okay? In comparison with us, that we use the 24 Gauss point, right? Okay? So if you 15 Gauss point, so then it's very close. Yeah, right. So for now, you see in some cases, Gauss point just only for Gauss is maybe not enough. Okay, it's maybe not matched to some function. Okay, but as I told you before, in my research, I use just only for Gauss point is enough because my function is just only polynomial. Okay, it's maybe 50 degrees, 60 degrees. For Gauss point is enough. But some cases it's maybe not. Okay, you will see what happened to this function, to this kind of function. You may plotting the graph. You may plot the graph here. You see the process profile is something like this. Okay, according to the number of points that we subdivide into 20 section, 21 point. We have this profile, right? Okay, but if you use just only 4 Gauss point, what happened? So then you see now you may select actually this one. Okay, I will show the graph. To match it. Okay, you see for the actual case, we have the blue curve, right? We have the blue curve. This is for what? This is for the actual case that we would like to integrate. We would like to integrate the total area of this zone. But if we use for Gauss point, it's going to be at a yellow profile. This is a yellow profile, but you have to know it has a weight of factor. It has a weight factor to adjust the value of the area a little bit. Okay, but if you see the profile, it's maybe have a function that is maybe got some error. So then, in some cases, the Gauss quadrature is maybe not give us the good value. Okay, you understand? Okay, so when you solve the problem, when you apply this method to engineering application, you should know which one is better and which one has some limitation. And it's up to you. It is your choice to select which technique that gives you desired value. Okay. So for this problem, it is, I will not tell you that which one is the best solution, right? Okay, it depends. Okay, but you have to know how to answer it. It cannot ensure that this one is better because it's numerical, right? Okay, but you have to know the limitation for each. I will moving to the third problem before, and after that we will just come back to the second one. The third one is something like this problem. Hello. The third problem. The third problem is about the open channel flow that you will study in fluid mechanics. Okay, in fluid mechanics, it's maybe the problem is maybe something like this.
To adjust a little bit.
Okay, so for this problem, right, it is an open channel flow. We have three methods, right? Trapezoidal rule, zigzag rule, Gauss quadrature. Okay, we would like to determine the area of the river. We would like to determine the area of the river, cross section of the river, to predict flooding, okay, or the flow of the river for fluid mechanics based on continuity equation that you know the velocity of the fluid flow in the open channel flow. You have the cross section, you can predict the volume, okay, that is equal to A, B, right? Okay, so for this case, we would like to predict the area of the river. What do you think? Which one? Which one should be the best choice? We have three methods. Trapezoidal, zigzag rule, Gauss quadrature. Can we use Gauss quadrature for these cases? Can we use actually in application? We know that Gauss quadrature should give us very good value, right? It should give us very good value. Okay. But for these cases, imagine that you have a river. If we apply Gauss quadrature, what's happening? You need the value of the function. We need the depth of the river at Gauss point, right? At a specific Gauss point. So for example, if we have 4 Gauss point, if we use 4 Gauss point, so then we would like to integrate from 0 to 20, right? We would like to integrate from 0 to 20 at 4 Gauss point. At 4 Gauss point, if from 0 to 20, I will show you, okay? Even use this table, I change Gauss point from 0 to 20 instead, and if it's 4 Gauss point, it's going to be over here, right? Okay, so then, what happened? We replace the function of fc at this point. When x equal to 1.38863, we okay for that? And another point, it should be 6.6, 13.399, and 18.611. Okay? Can we find the model there? At this specified 4 Gauss point in 10 decimal digits. What do you think? Is it possible or not? It's not possible for an actual case, right? Okay, you have to ask the engineer or the surveyor that, okay, you have to go to the river and then go to the 4 Gauss point that I specified before. What's that then? It's about 1.399 or something. And that point you have to direct and make sure we the depth of the river and that point. Okay, in 10 digits. It's not practical, right? Okay. So Gauss point is maybe not suitable for this kind of problem, right? Yeah, that's it again. So, which method that is maybe better than this? Okay. So we may select trapezoidal rule or Simpson rule, right? Because we can specify the range of the value between each segment easier, right? For example, like this is about around 0.2 foot. Okay, around, sorry, 10, right? 8, 6, 4, 2, right? It's around 2 foot. For x value is around 2 foot. Okay, and for y, okay, we can use ultrasonic to find the depth of the river. We can use ultrasonic, okay, to approximate the depth of the river. And for each step, that is maybe between 2 foot, right? Okay, that is practical. So then Gauss quadrature is not suitable for these cases. Do you understand me? All right. Gauss quadrature is not suitable. And now we have 2 choices. Simpson rule and trapezoidal rule. Okay, can we use Simpson? We have to, from our data, we have to count. How many segments? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 segments. Can we use Simpson? Yes, because Simpson requires even segment, right? So this problem we can use Simpson also, right? We can use Simpson. And how about trapezoidal rule? We can use it or not? Yes, we can use. And this is your choice. What is your choice? If this is your problem, which one? You use sim sum, right? This one, sim sum, right? Why you use sim sum? It's more accurate because we already studied CVE 240 right? อาจารย์เชนโรเทลดาซิมสันรูis more precise แสดงเป็นซิมสันเลย Okay, that's okay, that's a good shot. That's a good shot. Okay, imagine that. Imagine that. You have to explain. Do not explain me. I am professor, right? You explain me, I teach you, I know what symptom is. Okay? But now, think about it. You have to explain to the layman, like the farmer, okay? Okay, like the general people that never study mathematics, okay? And they don't know symptom anymore. Okay. How can you explain them that? You predict the river cross section by symptom. It's very hard. Okay, it's very tough to explain. Okay, you can use symptom, but they don't understand. What is come from? Symptom, what the hell is that? I don't know. Okay, it's very easier to explain them by using the small pieces of Parkinson area, right? That's maybe make them feel better to understand how come all the Cross River cross section. It's up to it's I will not tell that since some rule is wrong. Okay, but it depends on the situation, right? Okay, in some cases we have to explain some people that it's not they are not engineer. They never study mathematics. Okay, so sometimes we may have to explain them in another way. That make them understand better. Okay, but in high accuracy calculation, you may give me by symptom. Okay, or you may have some approximation function to, and you believe that you can point out the value and the cross point. You can use that already. You understand? So numerical technique. It depends on application. Okay, everything is maybe not. It's not give you the precise value, not exact solution. But you have to know how to apply it and what is the limitation for each method, right? Okay. So for this case, how can we do it? For these cases, we have no function, right? It's very easy, right? Okay. For these cases, we cannot use Gauss, right? We cannot use Gauss because we have no data. We have no precise data at Gauss point, right? So then, Gauss pointer is not the good choice for this problem, right? We will use only trapezoidal system. It's very easy. Just create a table. Okay. And if you compare with the profile, Okay. For this kind of problem, it's not necessary to determine function rate because it comes from the data as x equal to 0, that is on the at the end of the river, both sides. X equal to 0 and x equal to 20. Okay, the depth of the river is equal to 0. It comes from this data. Okay, and for another point, when x equal to 2 from the profile is equal to 1.8, right? Okay, we just use the data, something like this. And after that, we proceed for horizontal rule inside. You will see, if you use horizontal rule, you will get the river around 63.2 square meter. Okay. If you use dim sum, you get 66.4 square meter. So now is it your choice? Is it your choice? Which one is you prefer? If you would like to predict something, we start. You have two choices, right? Horizontal rule. Horizontal rule give you just only 63.2. Simpson rule give you 66 point. For flooding, that the river will come from the north to Bangkok, and we found out this is how to prevent the volume of the water come pass through this river. Okay, which area is like inconsiderate inside? Which one? Flooding. For flooding, it's up to you, really. Okay, but for this two methods, okay, that we believe that is maybe around here. Is it an approximation solution, right? So then for these cases, you may know that when the reporter or the scientist or the engineer that predict something, they may predict in range. They not predict in precise. This is a good way to inform the people, you know, the risk of this is the way for risk and suspense. Okay, for these cases, we may know that, okay, the volume of the water is going to come from between around here. Okay, then we have to prevent. Okay. For the case of flooding, we may use the other side, because the water is going to come more than expectation. Okay. And if for the case if it is not flooding, it's maybe the weather is too hot, and we have a problem of the water supply. Okay, we replace more water. Okay, we replace more water from the ground to keep it in our reservoir or something, in that or something. We may select another choice. Okay, you understand? For the numerical technique. Are you ready? Okay. So that's the end for numerical integration. Can you have some idea to apply it? Okay. Are you all right? Do you have any question? No? Great. Be back to finite difference. Okay. Finite difference is used for predict the differentiation term. It's used to predict the differentiation term. Okay. For example, we would like to predict the the first derivative of this function, Actually, this function is very easy to take the first derivative, right? But I would like to show you that what happened if we approximate it by finite difference. Finite difference, we have three ways to approximate it. First one, we call forward difference. Second one is a backward difference. And the third one is a central difference. Right? Okay? Central difference normally give us more precise value. Right? It's good, it's better than forward and backward. Forward and backward is the same order for error. Okay? Central difference is saying give us more precise value, right? Okay. So for these cases, if we use the general formula, we have the forward difference formula like this case. Okay. Order S. You see that we predict the first unit just only two terms, right? Okay. In the same manner for backward. For general formula, backward difference, we use this case. Okay, we use this case. You see, for backward, we use the value before the point that we specify. We use the value of xi minus 1, xi minus 2, xi minus 3. So on. Okay. But for central difference, we use both forward and backward value. Okay, to approximate the derivative at a specified point that we would like to determine. Okay. And the error for central difference is maybe less than the forward and backward. It's less than forward and backward. Okay. And for other cases, we may select the formula as we call the high accuracy formula. For high accuracy formula, we have three methods. We have three ways also: forward, backward, and central. But if you observe that for high accuracy formula, for forward, you will use small term. For general formula, you use a three term, right? But for high accuracy, you have to use three term. Okay, it gives us more accurate value. Okay, so this is just substitute the value inside. Okay, based on this formula. Okay, right? You use actually this case, and you may do it by yourself after class. So for this case, I may set up the Excel like this. I will not give you this table, and I think because of the limit of time, so then this is very easy. You may do it by yourself. Okay. So for the first function, that is a equal to y sine x. Okay. The first derivative of sine x, this is the exact solution for each function that we already know, and this is the exact solution in order to compare the result. Okay, we would like to compare the result for obtain for the exact solution. This is the exact solution because you can take derivative of that function and you got a new formula for the first derivative, right? Okay, this is the exact solution. Okay, and you got this solution. This is the exact. These are the exact solution. And for the finite difference, we use the first forward difference. Okay, you may create a table like this that is xi is over here, xi. That means let x equal to pi over 4, right? X equal to pi over 4. This is pi over 4, right? This is pi over 4. Okay. So actually, I think we may have time, right? We may have time. So then I will show you just one example, right? Okay. We have xi. Okay. But the problem is what? We would like to determine when x equal to for I will working out just only for problem A. Here, right? For problem A only, right? For problem A is equal to pi, right? Over 4. Okay? And s is equal to what? Pi over 12, right? Okay? So this value is equal to this one minus h. Okay? And this is equal to this one minus 2h. Okay? And this should be this one plus h rate. And here it is. Okay, we have this value, right? Okay. And the function is y equal to sine x. So we will use the formula here. If we use forward difference at first. We require this value, right? F xi plus 1 f xi divided by h, right? Okay. Okay. Fxi minus 1 is equal to what? Is equal to, because we will solve for the first function, that is y equal to sine x. Okay. Great. You okay for that? Okay. And then we will solve for the first forward difference. Forward difference of OH, that is the general formula. And this is for backward. Is for central. Central is OH2, right? Okay. So for forward difference is equal to what? We use this formula for forward difference. Okay. For first derivative, we will determine df. We will determine df for first derivative. Okay. Forward difference is equal to fxi plus 1 minus fxi. Okay. And it's divided by h. You okay for that? Okay. This is the approximation for the forward difference. And we would like to determine the percent error, right? Okay. For percent error, we have to know exact solution, right? Exact solution is what? For the function of sine, we take derivative of sine function, it should be cosine, right? Cosine what? Cosine x is here. Okay, this is the exact solution, right? Okay, so what is the percent error for these cases? Percent error we determine from the difference between the value for numerical divided by the norm. It should be the exact value, right? The norm, it should be the value that we ensure that it is the correct value. If we know exact, it should be the divisor like this. And we found out is 14% for forward difference. Are you right? Okay. And if we determine for backward, we use this formula, right? For backward is what? Is equal to fx, fxi minus fxi minus 1, right? And divided by h. What do you think? Okay, and here is what? Around 12%, right? It's around 12%. In comparison with the central difference is over here. This formula, right, is equal to what? Fxi plus 1 minus Fxi minus 1 and divided by 2h. And then again, it's around 1.13%. Okay. Can you see the difference between these three methods? Can you see the difference between these three methods? Okay. This is just for the general formula, right? Okay. And now we will use more accurate. For more accurate value, we will apply this formula instead for more accurate. All right, because I determine the value for xi plus 2 and xi minus 2 already. Okay, so we will determine for more accurate. So for more accurate formula forward, this will be OH2. Okay, backward is OH2 also. And central is become OH4. Okay, so for more accurate, for forward difference, we use what? We use this formula, right? Is equal to minus fxi plus 2, right? Plus 4 times fxi plus 1. Okay, minus 3 times fxi and divided by 2h. And we get here standard error is equal to what? In comparison with the exact solution, right? Okay, it's reduced to 7%. Okay, it's reduced to 7%, right? Okay, and for backward, what's happened? Backward, we use this formula and s is equal to what? It's reduced to 2.6% now for more accurate. Okay, and in order to for central is this formula, right? Central is what? Central is this formula that is minus fxi plus 2 plus 8 times fxi plus 1. Okay, minus 8 times fxi minus 1. Okay, and plus fxi minus 2. Okay, and divided by 12 s. Okay, and how about the percent error? It's around I may do something wrong. All right, I may do something wrong. Can you help me? B6. Okay. Oops. Here. Oh, Okay, I found it. Okay, this is my fault. Okay, it should be here. Okay. Okay. Thank you very much. Okay. So you see, if you study the clip review video, okay, you may you may have to be careful on that. Okay, because I select the cell missing something. Okay. So according to my experience, I know that my solution is maybe not good enough. Okay, so then I know that it's maybe not correct. And thank you for your friend that mentioned that. Where is my mistake? Okay, so it's normally, generally, it can happen like that. I have many experience, but in some case, when we do something in life, so then it's maybe have some mistake. We have to recheck it. Okay, don't worry about that. Okay, when we found a mistake, we just correct it. And you see that if we use more aggressive formula, it gives us very good solution, right? When we stop for the when we correct it, okay, at this term, okay, that is we select the value missing, okay. I'm missing the value for this, and it should be correct, right? Okay, this is alright. Okay, so do you have an equation? So for this case, you will see when we select pi over 12 for as the number as h, if we use it for smaller one, what happens? If we use it for smaller one, for example, it is pi over 20, what happens? It's maybe more accurate, right? Okay, and if we change it to be 200, what happens? Percentage difference is very close to the exact solution, right? And you see, for more accurate formula, okay, and you see that the error is very close to the desired one. So then I think your calculator may use a more accurate formula, and they specify h is very small. H is very small. So do you understand? Okay. And after this, can you solve it by yourself or just only two problems? Okay. Or just only two problems that is about cosine and log x. Okay. It's the same procedure, change function. Okay. And then try to, I recommend you to do by hand at first. Determine by hand because it maybe make you have more feeling. Okay, and after that, when you like to determine in non-defined number, okay, you may use Excel, create Excel again, in order to make you understand it better. And keep your mind up is favorite exam. You would have not allowed to take the computer inside. Okay, you have to practice to use calculator and solve like that. Okay, do you have any question for today? You have any question? For another problem, like the cosine and logarithm function, the solution is very something like this. Okay, the table is very different. It's very it's up to you. That which one that make you feel better, that make you more understanding, you may go that way. Okay, don't worry. Okay, and this is the solution. Because I still record, right? You may do it by yourself at first, and after that, if you would like to check the solution, you may open the video and go to the end of the video, and then you will see the solution for last two problems, right? Okay, this is for the last one, and this is for the second one. Okay, and then first, we will have solutions. So if you have no questions, thank you very much for joining this class today, and see you next time. Next week is the individual assessment. Prepare yourself. Okay.